Okay, what's the risk of
Okay.
I don't know, Miss Russell. What is the risk of actually getting salmonella from eating raw cookie dough?
It could be significant and it could kill you. Now, this is what we're working on now. If you're at home, they have copies of this. So if you're at home, you can copy as you're watching this, which would be super smart. That would be super smart. Okay, here we go.
You already missed school.
Now, listen to my words. This, what I have photocopied for you is not complete. There's some blanks that you're going to be filling in, obviously. Then there are some slides that are in my PowerPoint that are not photocopied. Those you'll be copying. Okay? Now, my suggestion to you, as you wish, is to, let me stand over here so people at home can see. If we needed to add a slide like after this slide, you could flip the paper over and put it on the back of the next page. You could grab a sheet of notebook paper and put it in between there if you want the lines. It doesn't matter to me. Just know that you're going to be adding to this. We're going to be making some margin notes. We're going to be doing all sorts of craziness. Okay? So just roll with it. Okay? Roll with it. All right, here we go. Put your pen in your hand. You need your highlighter as well. You're going to need your calculator today. Periodic tables are not required at this time. Okay?
Calculator, anybody?
All right, here we go. We're going to begin today by talking a little bit about acids. You do have a typo on this page, and I'll tell you when I get there. Now, acids have a sour taste, typically. Not that you should ever identify a compound by tasting it. Okay? You should not. Acids have a pH of between 0 and 6.99. Between 0 and 6.99.
I have a question. Who do Will go from with? I saw on Facebook that I've never seen that girl before in my life.
She does do that.
Yeah.
Okay. Now, acids contain hydrogen. You guys know this. We've already talked about this. If you have an acid, you see the formula, and the formula starts with H. If it's not water, it's an acid. HBr, hydrobromic acid. H2SO4, sulfuric acid. Yes? You guys know this already. So they all contain hydrogen. Okay? What that means is, because they contain hydrogen, when the hydrogen and whatever it goes with, so if I am hydrochloric acid, I am a combination of hydrogen with a plus charge and chlorine with a negative charge. When they go into water, when you take hydrogen chloride, which is actually a solid, and you mix it with water, it turns into hydrochloric acid. You have the hydrogens with a positive charge that break off from the chlorines, and then you have chlorines with a negative charge in there. Okay? If it makes hydrogen ions when you add it to water, it is an acid. The hydrogen ions don't come from the water. The water doesn't actually do anything. Okay? Now, this idea, the idea that acids contain hydrogen and give hydrogen ions when added to water, this is according to the Arrhenius and the Bronsted-Lowry theories of acids and bases. Listen to my words. Arrhenius and Bronsted-Lowry theories of acids and bases are very finely distinguished between each other. There are other acid-base theories that we do not care about for the Virginia Standards of Learning test. Do you follow what I'm saying? Do you have to learn other acid-base theories?
No.
Are there actually acids that don't contain hydrogen?
Most
Yes.
likely. Of course there is.
But we don't have to worry about that. You don't have to worry about that until you leave high school chemistry and go to Gen Chem in college. Okay? So, Arrhenius and Bronsted-Lowry theories. Why do I give you these names? Here's why. You're taking the SOL test, and there's a question, a very simple question about acids, a very simple question about bases. You can find the answer. It's no trouble. It's easy peasy. But they don't ask you about acids and bases in general. They say, according to the Bronsted-Lowry theory of acids and bases, comma, da, 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 and then you have to pick it out. And you see Bronsted-Lowry, and Ms. Russell never even said it or showed it to you before, and you go, I can't do that. It's the bestest, easiest question ever. Like, according to the Bronsted-Lowry theory of acids and bases, acids will have a pH of between 0 and what? And the answer is 6.99, but you see Arrhenius and you go, I can't do it, I don't know what that word is. This is literally the only reason I'm giving you those two words. Do you understand? Literally. Okay? So that you are not in the SOL test and going, I don't know what that is. If I have taught it to you in regards to acids and bases, it's according to those theories. Okay? The state of Virginia wants you to learn those theories in general. And I've summarized them as quickly as I can. This is the theory of acids according to those two theories. Okay? Now, this, I've given it to you on this slide because it's about acids, but it's not going to become relevant or practical to you until a couple slides. So bear with me on that, okay? pH, which you guys all understand pH at least a little bit, and we're getting into it now. Remember I told you earlier in the semester, when we first learned about acids, how to name them, how to write the formulas, I said we're not really talking about acids because it's going to be more later. It's now later, okay? We're getting into it now. Now, pH. If you want to make a margin note about this, I think of pH, and this is not an incorrect way to think about it, as percent hydrogen, because that's really what it is.
That's smart.
Okay? It's how much hydrogen is in that. The more hydrogen you have, the lower your pH is going to be and the stronger you are going to be in terms of acidity. The less amount of hydrogen you have, the more basic you're going to be and the higher your pH is going to be. Okay? So, pH is defined as, and it has a formula, and this is a formula you need to know, but it's super easy. Okay? pH is the negative log of the hydrogen ion concentration. Make yourself a note. Anytime you see these brackets, in chemistry and science it doesn't matter, anytime you see brackets around something, it is concentration of. That's what it means.
I have a question.
Yes.
Chemically speaking, which one is more dangerous, acids or bases?
They're equally.
So if I were to ingest an acid, so to say, like bleach, that's an acid, right?
No, it's a base, strong base.
Never mind. What's it, like, hydrochloric acid, if I was to ingest that, and then like a month later I was to ingest bleach, it would do basically the same thing to me?
Yeah. Chemically, different things happen, but they're both bad. Both of them will, the bottom line is that in terms of living organisms, both of them can destroy tissue. That's the bottom line. Yes, their mechanism is slightly different, but you're still talking about tissue death, cell death. Yeah? Now, listen. pH is the negative log of the hydrogen ion concentration, or, listen to my words, sometimes you are given pOH, and we're going to practice this in just a minute. If pH is percent hydrogen, then pOH would be percent hydroxide. Okay? Now, listen. We're going to practice it in a minute. Please remain calm. pH is, okay, that's why this big or here, okay? pH is the negative log of the hydrogen ion concentration, or 14 minus the pOH. And pOH is the negative log of the hydroxide ion concentration, which is on the next slide, and I'll show it to you in a minute.
Oh, so we're going to have to do that on the SOL test?
Yeah, but it's easy peasy. Now, this should be acids on your paper, and it says bases, and it's a typo. Fix that.
I like this song.
Okay? Listen to my words. You're going to have to make a margin note here, and it's super important. Okay? Aqueous solutions. That means that we've got an acid that is dissolved in water. Okay? Aqueous solutions of acids are electrolytes, which means they conduct electricity. Make yourself a note. Put it right here or put it in the margin next to this bullet. Doesn't really matter. Glowing light bulb. Do it right down. Glowing light bulb. Shane, if you touch your phone one more time, I'm taking it. Is that clear? Thank you. Glowing light bulb. What does that mean? Listen to my words. There's probably going to be an electrolyte question on the SOL test.
Oh, Lord.
9 times out of 10, there is either the answer choices or the question itself shows you a picture of a beaker with a solution in it, and then there's a light bulb. Either stuck down in the beaker or it's got some wires coming off of it. It doesn't matter. There's a light bulb. Okay? If the light bulb is glowing brightly when submerged in a solution, would that solution be a conductor of electricity?
Most likely.
Most definitely, because it's making the light bulb glow.
True.
And light bulbs need electricity to glow. Yes? Now, if I have a picture of a light bulb and it's glowing brightly, then the solution that it's in is a good conductor. If it's like barely glowing, and sometimes like it'll say underneath the picture, dimly lit, okay? Or the picture of the light bulb doesn't have like a big burst out of it, it just has like little bitty baby burst out of it, okay? That would be not conducting electricity very well, correct?
True.
If you have the light bulb stuck into a beaker and is not glowing at all, then that solution would be not an electrolyte. Capiche? That's
So are
electrolytes.
bases electrolytes?
Bases are electrolytes also. Okay? Now, and we're going to get to that. Alright, so moving on to bases. Bases have a sour taste. Some people actually say that bases are more bitter than sour. There's kind of a fine distinction. Sour typically is a pucker. So when you guys think about sour, naturally occurring sour, lemons, grapefruits, limes, things like that. Those are naturally, they have tons of citric acid, okay?
So those are acids, right?
Yeah, yeah.
Okay. Just making sure.
Bases are slippery. Bleach, shampoo, laundry detergent, bath soap. That slippery
Bath
feel.
salts?
They can have some base in them, yes. But it's that slippery. Have any of you guys ever gotten bleach on your hands?
No.
Pure bleach on your hands?
No.
Not that you should pour bleach on your hands, but if you do and you go to rinse it off, okay, you go to rinse it off, and you put your hand underneath the faucet and you rinse it off, and then you feel your hand and it's still real slippery. So you rinse it again, it's still real slippery. You have to like scrub it off, okay? The same would be true for, as I said, shampoo, detergent, bath soap, anything that we use bases to clean, very typically, okay? Something that is a super strong base would be something like oven cleaner. Spray it in the oven, it foams up, you shut the door, you come back and you wipe off the burnt stuff. I mean, it's pretty serious, okay?
So what if I ingested that?
Peace out. Now, bases have a pH of between 7.01 and 14. What number have I not mentioned?
7.
Exactly 7.
Neutral.
Because exactly 7 is pH neutral.
I knew that.
Now, bases, guys, this is super important. You may want to underline this. This is really important. This is the first time we've talked about it. Bases contain hydroxide. We learned earlier in the semester that all acids, for us in the state of Virginia in high school chemistry, all acids start with what? Hydrogen. We are now adding to our thing that we know. All bases end with hydroxide. Acids are ionic substances. They are hydrogen with a plus charge together with something negative.
Mm-hmm.
Bases are something with a positive charge. Sodium is the one we use most often. Magnesium, calcium, it doesn't matter. Something with a positive charge with hydroxide. We don't change the name at all, so we didn't talk about bases earlier in the semester because we don't call it sodium hydroxide base. Like we do hydrochloric acid. Like we say that in the name.
Are there
Okay.
any foods that we eat that are bases? Like you said, like lemons and stuff are acids. Are there any foods that we eat that are bases?
Not really. Not really.
Okay.
Now, listen to my words. Remember I told you there was like a baby fine distinction between Arrhenius and Bronsted-Lowry theories? Okay? Bases contain hydroxide, which is OH with a 1 minus charge. That is according to the Arrhenius theory of acids and bases. According to the Bronsted-Lowry theory of acids and bases, a base is a hydrogen ion acceptor. What does that mean? That means it's something that attracts hydrogen with a plus charge. It so happens that nothing attracts hydrogen with a 1 plus charge better than OH. Okay? Very fine baby distinction. Okay? Very fine distinction.
Basically, it's the same thing, but this Bronsted-Lowry guy wanted to say it in a cooler way.
In a hoity-toity way. Yeah, you can go with that.
So this guy who's boss.
Now, POH. What did I tell you pH was? I said it was percent hydrogen. POH is a measure of how much hydroxide is in a particular solution. POH is the negative log of the hydroxide ion concentration. You can do this in your graphing calculator. It's magic. We're going to practice in a minute. Okay? Now, aqueous solutions of bases are electrolytes, just like acids. They both are solutions that can conduct electricity. Okay? Now, let's talk about pH. Alright? You're going to need your calculator.
Miss Russell, how much would you like to go to my locker and be back in 30 seconds? Would you let me?
What do you need?
Pack of crackers and Hungry.
I'll give you the crackers.
I have a box of them in my locker.
You need to hustle because we're
Run.
Okay? So the hydrogen ion concentration of a sample is 1 times 10 to the negative 6.
Don't maybe start running.
That's so good.
That was my clicker.
Oh no.
Excuse me. 2 batteries. Oh, I wonder if it's still going to work.
Hey, what kind of batteries does that take?
Triples.
Let me see. I think I have those. They're in that color. It's a small pack. I was supposed to be able to Mr. Adams, but I never.
She threw a clicker at her seat because she was so angry you were gone.
Still works. Look at that magic.
Why'd you throw a clicker?
I did not mean to.
Why'd you throw a clicker?
I did not. It slipped out of my hand. Okay, now.
I think she threw it. I was doing it in here.
I need a new
Phil
rubber
came
band.
outside and he was like, "Is that you running?" And I was like, "Yeah." He was like, "Don't." And I was like, "Don't tell me what you're doing." He's like, "Okay."
Okay. The back has been broken for a long time, so it's my redneck clicker. Woo, woo, baby. Okay. So pH is negative log of the hydrogen ion concentration. So in your calculator, you clear it, you have it on, you clear it, you hit negative and then log, and it gives you a parentheses. And you put 1 times 10 to the negative 6, 1 times 10, raise it to the negative 6, close the parentheses, enter, and we have a pH of 6.
Yeah, it is easy.
Yeah.
Is that a non-unreal number or something?
Shape's like his.
Yes, you did.
You're eating 2 of them?
Yeah.
Negative log
Crackers?
1 times 10. Raise it up.
You can run them all. Get
Negative
that.
6. You hit the divide button.
Wow,
Close
664. My
parentheses.
combination is 11, 27, 16.
Okay?
Roger knows how to do this.
Girls. Now, let's look at another one. Okay? The hydrogen ion concentration of a solution is 2 times 10 to the negative 7. 2 times 10 to the negative 7. pH of the solution, so negative log of 2.0 times 10 to the negative 7. Do it.
Oh, yeah, how many decimal places do we go?
Excellent question. Did you hear Marina's question? She said, how many decimal places do you go? For pH, 1 or 2.
One.
Truly, it really does not matter between 1 and 2. You probably definitely want to keep 1 unless it comes out even, Steven. Like this one here was 6. Don't make it 6.0. That's ridiculous. Okay? On pH, it's not, we don't have to stress about sig figs and all that craziness. Okay? So what is our answer here? 6.7. So let me ask you this. This solution right here, with a pH of 6, is this an acid or base?
Acid.
Acid. Because acids are pH between 0 and 6.99. Acid or base? Acid. Okay? Now, okay. Do not do this without me. Just pause a moment, just chill a moment and listen. Listen. You have 4 problems, A, B, C, and D. And you have to determine whether each of them is an acid, a base, or is neutral. Now listen to my words. Letter A and letter C are just like what we just did. You just do the negative log. Do you understand? This one, choice B and choice D, or not choice rather, excuse me, letter B and letter D problems, go back to the slide on acids. Go back to the slide on acids.
14.
Okay? If you have the hydroxide concentration, which is not hydrogen, it's hydroxide, in order to calculate the pH, you have to take 14, which is the max on the pH scale, and subtract from that the negative log of the hydroxide ion concentration. Yes? Listen to my words. pOH, which is how much hydroxide is in something, is relevant only when it tells us what the pH is. We use a pH scale. Do you follow? We use a pH scale. We don't have pH and then pOH. The whole thing is pH. Okay? The maximum value must be 14. So, for this one and this one, it's going to be 14 minus the negative log of that. 14 minus the negative log of that. Okay? So let's go through A together. Let's do that one.
Yeah, I put that one in the calculator and they got negative 10.
I know, because there's a typo. Give a negative right here, please. That exponent should be negative 10. That's my bad. Yeah, that's my bad. Everybody fix that on your paper, please. Thank you. All right, so letter A, the pH is equal to the negative log of 6.0 times 10 to the negative 10, which is what?
What's the M for?
That's molarity. That's the concentration. We'll get into that later. What is the pH of letter A? 9 point what? 9.2. So, answer the question. Is letter A an acid, a base, or is it neutral? Claudia, you can't talk to me anymore. Everybody look at letter B. We are given hydroxide. We are given hydroxide, not hydrogen. That means we need to do 14 minus the negative log of the hydroxide ion concentration. So in your calculator,
Wait, where did the 14 come
acid slide.
from?
Because, Mary, I'm starting with OH, look right here. Because I'm starting with OH, okay, I have to have 14 minus that, the negative log of that concentration, okay? So, 14 minus, parentheses, the negative log of 3.0 times 10 to the negative 2 what do you get?
I got 12.5.
That's correct.
Okay.
So pH for this one is 12.5. Does anybody need help with the math? Okay, so what is that then? Base? Good. Alright, let's look at this one. This one is just regular negative log. Okay, so pH equals negative log of 2.0 times 10 to the negative 7. Shane, you can't talk to me anymore? 6 point what, Lindsay? 6.7. So what is this thing?
Can I call dibs on number D, letter D?
Okay. We start with hydroxide ion concentration, so we need 14 minus the negative log of 1.0 times 10 to the negative 7. So, Marina, what's the pH?
7.
7.
Therefore, it is neutral.
That means this thing is neutral.
What's that sound? It's like a high pitched, like kind of like shrieking noise. Do y'all not hear it?
No.
I think it's just gonna slide
Okay.
slowly crazy.
Now,
Do you really not hear it?
No.
Is that going crazy?
okay, listen to my words. This is what's in your, what we just did is in your notes. Yes? The very next slide in your notes says gases. That's not what's going to come up on the screen. So you need a separate sheet of paper, or draw yourself a line going across the page right here, like an arrow, and start writing on the back. However you want to do it. Get a separate piece of paper, stick it in your notes right here. Doesn't matter to me. Doesn't matter to me. The next, listen, the next 2 slides you're going to have to copy, like old-timey. Like back in the day, notes. All right, I'm going to pause the video for just a minute.